a whole year working, not a whole year, but a lot of last year working on slope-intercept form. There are two other forms of lines that you guys will be learning about this year. One is point-slope form, and one is slope-intercept form. So there's three different ways to write up equations of lines. So today we're going to focus on point-slope form and graphing from point-slope form. Tomorrow we're going to graph from standard form. Then we're going to start talking about transformations of lines, inverses, and deciding linear and nonlinear, and your test will be next week on the block. So next Wednesday for you guys. So first of all, deriving point-slope form from the formula. We know that slope is a change in y over a change in x. Do you guys agree with that? So you know to do y2 minus y1 over x2 minus x1. Point-slope form literally comes from the slope formula. So if you substitute x for x2 and y for y2, you get y minus y1 over x minus x1 equals m. All they did here was multiplied both sides by and you have point-slope form. So they multiplied both sides by the denominator, and you got point-slope form. So if you forget point-slope form, and you know the slope formula, you should be able to get back to it. Does that make sense? Does everybody see that? It's related to the slope formula. All right, so we then need to talk about what all these pieces are. What is y? What is y1? What is m? What is x? And what is x1? So after you got that written down, go ahead and flip to the next slide. Okay, so graphing from point-slope form. First, you're going to plot the point from the equation. So in point-slope form, x1 and y1 are a point along the line. It is not necessarily the y-intercept, although it could be the y-intercept, but it is any point along the line. So slope-intercept form only gives you one point, and that's the y-intercept, correct? Point-slope form could be the y-intercept, but it could also be any other point along the line. So this formula is nice when you're given a slope in another point that is not the y-intercepts, and you can't go directly into slope-intercept form then. So point-slope form has the point, and it's opposite x1, comma, opposite y1. That is the point along the line. So you take the x out as the opposite, and you take the y out as the opposite. So opposite just means change the sign. And the x will always be next to the x, and the y will always be next to the y. So it's in it looks like you should, a lot of kids just like to just drop it down, but that's wrong, because y should be the second term in point-slope form. So you're going to plot the point from the equation. That's the first step. You're going to determine your point, which these two give you your point. And you'll plot that along your graph. And then you're going to use the slope to plot at least 2 more points from your given point. So m is still slope. M is still slope, just like in slope-intercept form. So you're going to start at the point. And use m. So your point along the line is opposite x, comma, opposite y. Which means change your x, change your y, change the sign of it, and use the slope. And then you're just going to connect your points using your straight edge. So we're going to put this into play in just a second here. So I'll do the first one for you, and then I'm going to start calling on you guys randomly. So we're going to graph the following from point-slope form and scale the graph correctly. So some of these will not fit on the graph. I know that some of you got your homework already from Ms. Kroll, and you guys were complaining about how something doesn't fit on the graph. Part of this lesson is also scaling the graph, okay? So sometimes we have to scale it to make things fit. All right, so first of all, a lot of you guys would love to do this. Distribute and put it into slope-intercept form. Do you guys agree with that? Is that what most of you would have done when you saw this? Here's the problem, though. Your y-intercept is a fraction, isn't it? So is that completely accurate then? When you do that? So that's negative 1.5 plus 2, which so that'd be. So why is it better to do point slope form then? Do you know exactly where 1/2 is on this graph? No, it's in between, right? So you're kind of estimating where that point is. Do you guys agree with that? So instead, we're teaching you guys point slope form. So what you do is you determine the point. So your point is x1, y1. And you always take it as the opposite. So notice the y is with the y and the x is with the x. A lot of kids do this wrong and they'll take the 2 and the 3 out, right, like how they see it, because that's how you see it, right? It looks like it should be in that order. But y goes with y and x goes with x. So the x is -3. What's opposite of a -3? So our point is +3, comma. What's opposite of a -2? So that's +2. So again, x is with x, y is with y. Okay? So in the formula, it's y minus y1. When you do minus, that always means change the sign. So in any formula that has minus in it, that means you're changing the sign when you substitute something in. What is my slope? Who can tell me what my slope is here? Who remembers which one of those is your slope from the previous slide? Mike? Nope, be careful. We've already used 3 as x1 and 2 as y1. Denari? M is 1/2. So M is what's in front of that parenthesis there. So your slope is 1/2. So can you plot the point 3, 2 pretty easily? Mm-hmm. Yeah, that's a lot easier than plotting a half. So if we go 3, 2, we go right 3 and up 2 and we plot that point. And then we use our slope. We rise 1, run 2. Up 1, right 2. So up 1, right 2. Or I could go down 1, left 2. But notice, we don't have an exact y-intercept here. But our graph is so much more accurate because we use that point. So look at that there. Even if you would have graphed this one, you would have started at 1/2 and you would have gone up 1 over 2, up 1 over 2. So do you notice it's the same line? Either way, you're just at exact points by using point slope form. So I would like you guys to practice graphing from point slope form. I showed you that. That's what you typically would do, but this is how we are doing it today. Does that make sense? So what questions do you guys have so far? When you're ready, go ahead and flip. If you are completely lost and stuck, please, at least, on a test or anything, the EOC won't care. On a test, as long as it doesn't tell you to graph from a certain form, we don't care. Like, you could always go back to slope-intercept form. Does that make sense? But on your homework tonight, I would like you guys to practice graphing from point-slope form. On the test, it won't matter. All right? So if you need to put everything in the slope-intercept form for the test, completely fine. Does everybody understand that? Got it? Unless it says otherwise. All right, so it says graph the following in slope-intercept form and then scale it. So here's another reason why we might want to do that. If you distribute this in, what's going to happen? What's going to happen if you do -2/3 times 5? What are you going to have? How good are you guys at dealing with fractions and moving things around? Not so good. Some of you guys are fine. If you guys would use your calculators, you would be really good, but some of you still refuse to use calculators for whatever reason. But it makes it more difficult for you guys. So that's why it's better just to use point slope form. So what is my point? What is my point then? Cassie, what is the point we can pull from this equation? -5, comma 2. So x goes with x. So this is x sub 1. Opposite of a +5 is a -5. Y goes with y. Y is right here. So this is y sub 1. Opposite of a -2 is a +2. So that's how she got that, okay? Jayla, what is my slope? -2/3. Good. So we should have a negative slope. Remember, that means it goes downhill. Okay, so we plot the point -5, 2. And you use your slope from that point. Are you on a different problem than I am?
Yeah.
Oh, okay. I was like, why are you plotting it down there? That's fine. I was really confused for a second. Down 2. If I go down 2, Justin Powers, if I go down 2, am I going to have to go left or right 3 to make it negative? Left or right to make it negative? So if I go left 3 and I connect that, will that be a positive or a negative slope?
Oh, I thought you were talking about the other way. Right.
We'll go right. So we go down 2, right 3. Will that make a negative slope then? So these are also things you should be asking yourselves. Am I going the right way? Also notice it's not crossing over the y-intercept at an exact point. This is why knowing point-slope form can be helpful. Okay, the last thing that's in there that you guys can see, and I didn't see it on the last one, is name a solution. So Blaine, give me any solution of this line here for example 2. -5, 2, just the point you pulled from there. You could have chosen any other point along this line. You could have told me -2, 0, right? That's a point along the line. So any point along this line is a solution. Questions so far? How are we feeling so far about this stuff?
Okay.
Okay, it's new, right? It's different. Hopefully not too difficult, but it's different. Something new and different does mean that it's, it's something you need to learn. So it's okay if it is. Okay, again, this one would be fine for you guys to put into slope-intercept form. It would work out perfectly fine. That would be great if that's what you need to do. But we're not doing that for today. So, Josh, what is the point I could use for example 3? Perfect. I love how you corrected yourself. So you originally were going to tell me -1, right? But then you realized it needed to be the opposite. So again, just check that you're doing things correctly. So Josh said the x value is with x, which means it's -1. Opposite of a -1 is a +1. Good. The y value is with the y. Opposite of a +7 is a -7. Tanari, are you okay? Are you understanding what I'm talking about? Okay, you're just giving me the stare. I just wanted to make sure you're good. All right. What is my slope, RC? -4. So we plot 1, -7. And our slope is -4. But can I go down on this graph here, Brian? So what could I do instead for -4? What could you do instead of going down? What could you do instead? Go. So if I go up 4 and I need a negative slope, which direction would I have to go? Left or right? Left. So if I go up 4 and left, I'm here. Does that make a negative slope when you connect them? It should. Give me a solution, Connor. What's the solution?
-2, 0. Oh, no, I graphed my... No, wrong graph.
You were looking at the... That's correct for that graph. Yes. Now the other one.
0, -3.
0, -3. Very good. All right, what questions do we have so far? We're almost done. And I'll get you guys your homework, and you can work on that. You can go after this. So this one says, graph the following. So we need the point and the slope. So Grace, what is my point? Good. And Jordan, what is my slope? Yep, there's a 1 there. You guys are doing good with this. Oh no! It doesn't fit. So it's easiest if you guys scale both the x and y axis the same. Because if you scale the x and y axis differently, it can sometimes get confusing for you guys. So I'm going to scale them both by 2s. I think that should fit it, right? So if I scale them both by 2, so this would be -2, this would be +2, +2, -2. And I'm only going to put a few on there that just so I know what I'm scaling by. You don't have to put a ton on there. I'll talk about that in a second. Because in the original equation, in the point slope form equation, Riley, this is point slope form. It has a subtraction sign. So if I were to take that point out of there, -6, -12, and plug it back in, two negatives make a, so it changes it to a positive. So that the subtraction sign in there means it's the opposite sign. So that's what that means. That's why that's done. All right, so we plot -6, -12. So -6. You'll see more of this as we're writing equations too. And then it tells us to go down 1 over 1. So if I go down 1, that's not the whole entire way, is it? No, down 1 over 1 would put me in between here, right? You guys see that? So I'd really have like a point right in the middle of this box. Then I go down 1 over 1. Do you guys see that I'm following my scaling? You see that? Now, if you went up 1 over 1, it would have worked the same. Because what's 2 divided by 2? 1. So that's why if you scale your graph the same on the x and the y, it won't matter if you do it wrong. It's a problem, though, when you scale your graphs differently. You guys have to really look at your scaling to make sure you're doing the right thing. You're going to have to be careful of this on the EOC or on science tests because sometimes things are scaled differently and you want to make sure things are done correctly. Yeah. Oh, you're good. Kaylee, what's the solution of this one?
Hang on. That's 4.
12, 14. Yep. So -4, -14. Look at your graphs. Did you guys make sure to label what you were scaling by, or did you leave that blank? Because I am going to assume if you don't write something there that you're counting by ones. Does that make sense? And I will mark you wrong. Does that make sense? If nothing's in there, the assumption is that it's counting by ones. If you have something written there, then we know you're scaling it. So make sure you put at least -2, 2, 4, that kind of a thing. That helps me know. You don't have to put that many numbers in there. Just 1 would actually be enough because I know you're counting by that many then. You're saying 1 unit is actually equal to 3. All right? So make sure you're scaling it like that. All right, Colin. This one looks a little bit confusing. What is my point?
Is it?
Think about this. If you multiply anything by 0, what happens?
It becomes 0.
So whatever was in here, it just became 0, right? So what is our x coordinate then?
0.
0, comma, what is our y?
-30. Or no, 30.
Positive 30. Yeah, and think about that again. If we added 30 to both sides, this would just be y equals 30. This is just telling us that the slope is 0. So this just gives us that our slope is 0 here. We know a y equals equation. So a few things that you guys need to remember. Y equals equation. Need to cut across the y-axis. It needs to cut the y-axis, not the x-axis. To cut across the y-axis, you have to go horizontal. Do you see that? So to cut across the y-axis is horizontal. So I'm going to count by tens here. So 10, 20, 30. We have a point here at that, and for it to be a y equals equation, it must cut the y-axis. It has a slope of 0. You can walk across it. You're saying that the incline is 0% essentially here. So it's just a flat surface. So give me a solution for this one. Give me a solution for this one, Connor. What? Something, comma. It's always going to be something, comma 30. What? So give me anything, comma 30. It's going to be a solution. 40, comma 30. That's a solution. All right. Questions?